Now here's the thing, space is pretty big. And if we talk about space in relation to things like the metre, our normal unit of length, it doesn't really allow us to actually really do the calculations that we need and really appreciate just how big it is. So what we have are three ways of measuring distance. Now the first way is we use something called the astronomical unit. And the astronomical unit is basically AU. And this is fairly straightforward. What this is, this depends upon basically our sun, which is here, and also the Earth. And basically, if this is the Earth and this is the sun, one astronomical unit is the mean distance between the Earth and the sun. And obviously it changes very slightly due to the very slight elliptical orbit that the Earth has. And this distance, so 1 AU, is equal to 1.50 times 10 to the 11 metres. And this is really useful if we kind of talk about things within our solar system. So if we talk about the distance between a planet and the sun, if it's less than 1 AU, then this will be a planet closer to the sun. But we might think about things like Jupiter and other things which are a lot further away. And then we just kind of get a rough idea of where these things are in relation to the other planets. So this is the first unit, which is 1 AU. Now the second kind of distance that we use is one that you're very familiar with, and this is the light year. And the light year has a symbol of little l and little y. And this is really important. It's not a length of time, as people often assume, maybe perhaps at GCSE or before that. But basically we can think about distances in terms of time like this. So for example, you might live perhaps a 10-minute walk away from school, or it might be a 30-minute drive. And we're often used to expressing distances in terms of time. Now, a light year is just the distance that light will travel in a vacuum in 1 year. So if we know that we know that basically x is equal to vt, so displacement is equal to the velocity times time. If we talk about light, we know that the velocity of light is the speed of light, because that's what it always is in a vacuum. And therefore we can say that the distance that light travels in 1 year is equal to the speed of light, which is 3.00 times 10 to the 8, and we multiply that by the number of seconds in 1 year. So it's just 365 times 24 times 60 times 60. And if you put all of these numbers into your calculator, you can then just kind of check that 1 light year is equal to 9.46 times 10 to the 15 metres. Now that is a pretty big distance. But space is a pretty big place. For example, our galaxy, the Milky Way, has a diameter of about 100,000 light years. So even though light and photons will go very, very quickly, they still take a huge amount of time to move all the way through space. So this thing here is a really useful way of looking at very, very distant objects. But there's one more way which you might not be so familiar with. And this final way is what we call the parsec. Again, parsec has a symbol little p, little c. And this one here, it's actually quite a useful measurement, although it's often not really talked about in science fiction and so on. So what do we know? Well, first of all, if we have the Earth and we have the Sun, we know that the distance between these two objects is equal to 1 astronomical unit, which is 1.50 times 10 to the 11 metres. And perhaps we have a star which is some way away. What we can actually do is look at the distance to this star in terms of the parsec and the angle that it makes when we actually observe it. And I've kind of exaggerated the triangle quite a bit here. So basically we have an angle here of theta, and basically when the angle of theta is equal to 1 second of arc, this distance along here is equal to 1 parsec. So what is 1 second of arc? Well, basically inside a complete circle, we have 360 degrees. Now each degree can be thought of as, so 1 degree is basically equal to 60 minutes. So we can just take this kind of 1 degree, we can sort of split it into 60 pieces, and then we can think about splitting each of these minutes a bit further down. And what we can say is that 1 minute is equal to 60 seconds. And this is kind of useful a long time ago when people did lots of navigation at sea. So basically inside a circle you have 360 degrees, each of which has 60 minutes and each of which has 60 seconds. Now basically if this angle here, theta, is what we call 1 arc second, or 1 second of arc, that's basically a 60th of a 60th of a 360th of, that kind of complete circle. And so basically what we're talking about here is a very, very small angle. Now, if we think about a bit of, SOHCAHTOA, we can maybe think about this angle here being a certain angle. We've got the opposite side over here, and here we have the adjacent side. What we can then think about is the adjacent side is equal to the opposite side over tan theta. And in this case, the adjacent side would be equal to 1.5 times 10 to the 11, which is equal to the opposite side, which is 1 astronomical unit, so expressed in meters. And then we can then look at tan of theta, and theta is just 1/3600th of a degree. And if we put those numbers into our calculator, we find that the adjacent side, so this side here, 1 parsec, is equal to a total of 3.1 times 10 to the 16 meters. So 1 parsec is this length here, and you've got to be able to, sort of just recall that number because it's useful when we look at things like Hubble's law very soon. So just to summarise, we have the astronomical unit, the mean distance between the Earth and the Sun. We have the light year, which is the distance that light will travel in a vacuum in 1 year. And finally, we have the parsec. And the parsec is a distance when you basically have 1 second of arc over at this point over here. And that's really useful when we come to the next video and look at things like stellar parallax.